Hi there. Welcome once again to our Smart Mates session. I'm Sito Bejane, and in today's session, we'll still continue with our power supply for Module 2 Industrial Electronics. Today's example is extracted from example 2.16 from your Industrial Electronics TVET First textbook by Tropent and Macmillan Publishers. Now, what we are looking at today is an RC pi filter type of a circuit. I want to believe that you already possess adequate knowledge from industrial electronics and for about this type of circuitry. Here, we know that this filtering comes after we have rectified a certain circuit. Of course, this still falls part of the typical DC power supply family. Now, in our example here, we need to be calculating certain components of this circuit. Without the waste of any time, let us dive right into it. The example reads as follows. In figure 2.37 below, the full wave rectifier RC pi filter circuit operates at a frequency of 50 Hz with a DC voltage of 150 volts and and a V ripple RMS 15 volts, whilst we have a resistor of 500 ohms, C1 being 15 microfarads, C2 10 microfarads, and the load resistor being 5 kilo ohms. Now we need to determine one, the DC components of the output signal across the load resistor, the AC components of the output signal across the load resistor, as well as the ripple of the output waveform in the frequency. Now, for you to be able to calculate this, you must ensure that at all times you understand the formulas that are provided to you. And in this book, we've ensured that formulas are provided to you in a table form. That table should be used as a guideline for your calculations. Now, we are going to divide this into two sections. We'll have the DC components and our AC components, just like that. Now, because this is a full wave rectifier, we need to be careful in terms of choosing the correct equation that we use. Right. Let us look at this. What are the DC components on this type of a circuit? Because we are calculating the components across the load resistor, and anything across the load resistor must have a prime. If you're talking about a current across C2 or the load, if you're talking about the ripple voltage, if you're talking about the ripple factor, if you're talking about the DC voltage, they will all have a prime. Which means that, let's make a simple example. In the input side, we are going to have our input DC voltage, our input DC current, our ripple factor, our ripple voltage, just like that, right? This is across C1. Once an examiner says calculate this and that across C1, calculate the current supplied to the rectifier across C1, they are talking about inputs. We call this our inputs or input components. But if the examiner speaks of C2 now, C2, we're still going to have the same components, but they will have primes. V prime DC, I prime DC, R prime, V prime ripple RMS. These are applicable on the what? On the output. Right. Now, what is it that we are looking at here? The question wants us to calculate DC and AC components across the load. Where do we find the load in the circuit? On the output side. It means anything that you'll be calculating here should have a what? A prime. Perfect. Now, what is the DC component of the signal across the load resistor? We're going to use the equation V prime DC, which is equal to R load, R multiplied by VDC. Do we have VDC in the circuit? We do have VDC in the circuit, which is 150 volts. It is already provided in our statement. Do we have the load resistor? Yes, we do. Do we have the series resistor? Yes, we do. Now we need to calculate the output DC voltage. That is the DC component of this circuit, right? Make sure that you study your equations like I alluded. Now this is going to be 5,000 plus 500 multiplied by 150. Remember what I always preach about a calculator. Ensure that when you enter the exam room, before you start calculating, you reset your calculator. One simple advice that I always give to my students: you have 3 hours to answer an exam paper that consists of 100 marks. In the event where you were so fast and managed to finish the whole paper in an hour or maybe in 1 hour and a half, good people, you still have much time to be in that center. Avoid rushing, leaving the center. Do not rush. You have 3 hours full. Use that time. Sit, verify. Do not leave empty spaces. Make sure that all the spaces are fully used, fully written. There's no empty space. Make sure that you check your work thoroughly. SI units, substitution, calculation, even definitions, theoretical questions. This will assist you to gather as many marks as possible. Stay in the exam center until the invigilator says time is up. Do not leave. At the end of the day, what are we rushing? Now, this is 5,500 multiplied by 150, and we get 136 point, that is 136.364. 136.364 volts. That is 136.364 volts, right? 136.364 volts. Now, what are the AC components? Right? The AC components in this case, we need to calculate the capacitive reactance. AC, when we speak of AC, you must know that whatever is there will be influenced by frequency. When we speak of DC, you must know that the impact of frequency is nullified. It may be there, but well, it's negligible. But on AC components, frequency will be a binding factor. Therefore, any equation that we use, they must consist of something that is related to the frequency. Now, I said this is a full wave rectifier. Therefore, instead of me putting 2 pi fc here, I will put a 4. Check your equation. This will be there in that equation. This is 4 pi 50, and what is the capacitor across the load resistor is 10 exponent negative 6. That is 10 microfarads, right? 4 pi 50, 10 exponent negative 6, and we get 159.155, 159.155 ohms, right? Then that means the AC component would be your ripple voltage. It won't be DC voltage. DC voltage is a DC component. Ripple voltage is an AC component. We use the equation XC divided by the root of R squared plus XC squared, all multiplied by the input ripple RMS. Just like that. Just like that. 150.155 divided by the root of what is our R, 500 squared, fix that, 500 squared, 159.155 squared, right, multiplied by our ripple input voltage, which is 15. Our ripple input voltage, which is 15, this will give us 4.55 volts. That will give us 4.55 volts. That is the AC component of the load on the output side. And then the question also wanted us to calculate the ripple factor here. Also wanted us to calculate the ripple factor. Now, let us calculate the ripple factor here. The equation to calculate the ripple factor will be R prime is equal to V prime RMS divided by V prime DC. Look at this. You are using both that and that. So if you have calculated incorrectly, you will face a very serious challenge. Nope, that is not correct. Let me punch that. Divided by 136.364, that will be 0.033. 0.033. No SI units. That is how you tackle this question. That's how simple it is. That is as straightforward as you'd want it to be in this type of a circuit. Now, take note of your equations when it comes to power supply. There are so many equations, I understand. Some of them might even cause cognitive overload. Some of these equations are so similar that you won't even be able to spot their differences. But when you start, you ensure that you have a formula sheet that you use to practice. In your study timetable, have a time where you only practice formulas. You only want to understand formulas. And you keep these equations in mind. Once you have these equations in mind and in memory, this will also assist to save time in the exam, such that you would not spend too much time browsing through the question paper trying to find the relevant equation or formula, only to find that at a later stage, maybe you might not even be able to identify that type of an equation that you want to use. But when you familiarize yourself with these equations, things becomes much more simpler. That's it for me today, folks. Let's meet again next time for another exciting session of Smart Mates Industrial Electronics.